in this particular video, we have a batsman called Brett Lee, and he smashed a massive six and essentially hit the ball out of the ground by a horizontal distance of 143 meters. Now, this was back in 2005. So my sort of question is, how can we use existing maths knowledge from A-level maths to help us try and model this if possible? So what we can try and do is think about the sort of concepts that we need here. Okay, so when we think about mechanics, the one thing that really aligns with this is projectile motion. And in projectile motion, you've definitely come across the concept of a range, and the range is the horizontal distance that a projectile will travel. That formula comes out to this: v squared times by sine 2 theta. Sine 2 theta, let me just undo that, over g. Now, what are the sort of components here? Now, the v, if I actually should put v naught here, that is the initial velocity of the ball when it's hit. Okay, so if you've got the technology that can sort of tell you how quickly that ball left the bat, then we can get that value there for v naught, and that will be a horizontal velocity in terms of its initial. The next thing that we need to know is theta, which is the angle at which the ball is hit. And again, if you've got the technology that can tell you that angle, then that would be really good. And then the final thing is g, which is the gravitational constant, acceleration due to gravity, which we assume in mathematics to be 9.8 meters per second squared. Now, when we think about the angle at which a ball is hit, in the sort of realm of cricket, a high angle, if you hit a ball quite high in the air, it will go quite high. Sorry, if you hit the ball with a steep angle, so let's say, I don't know, for sake of argument, 70 degrees into the air, then the ball will go quite high, and it might not achieve that distance to clear a particular boundary. However, if you were to reduce that angle, let's say to 45 degrees, then you possibly will be able to achieve that horizontal range to get that 6 runs that you want to get for that particular shot. So there is a particular sort of, when batsmen train for hitting or range hitting for sixes, for sort of the big clearing those big boundaries, there is an art to that and making that angle the best angle to get that 6. So in terms of the mathematics involved here, not massively difficult to understand, but obviously we're being quite simplistic. We are ignoring certain aspects such as friction. We are ignoring air resistance. Okay, we're ignoring spin. That could have an effect. So when the ball hits the bat, there might be a certain amount of spin that's generated in the ball. We are assuming none of those aspects. So this is quite an in-depth, this is quite a simple overview in terms of the modelling in cricket, especially mechanics around a sports problem. And yeah, next time you hit a massive 6, remember, it's not just a powerful hit, it is that blend of velocity, angle, and the battle against the elements, all governed by fascinating laws of physics, which are underpinned by mathematical concepts.